Uh, Hello everyone. I think we're still in the morning, so good morning. Today, inshallah, I will go through lectures 5 and 6. We will start the part of functions. Mainly, we will be interested in functions in several variables, or functions mapping from Rn into R, which is functions in several variables. And it is the more realistic case, or the more general case, in plenty of applications, as you will see down the road. Okay, of course, all our course references, you will find them in Moodle. Also, I will try to send you most of the PDFs on WhatsApp, as I told you previously, the previous lecture. And also, I insisted in that you try to download, try to organize your desktop for this part. Try to have a main folder for mathematical analysis 2, under which you have two main subfolders, one of them containing the PDFs that I sent you on WhatsApp, or you download from the Moodle, which is related mainly to the slides from Lisbon, plus let another folder for the lectures running in the campus. The lectures running in campus, it's exactly like those in Lisbon. It's covering everything in them, going through the solved problems, the examples, and the books, plus more exercises, and the list, you will find it also solved with some of the problems from the previous exams. So try to keep them with you, and be familiar with them. Because Judy, once we come to the exam time, you will need something you are familiar with in order to review. So this is why it is really important at the time being to go through the PDFs more than once, to be familiar with them. Okay? And of course, the recorded lecture, you'll find them in our YouTube. Let me start with the formal definition of a function first, then I will go step by step. In general, we have three main types of functions. Miss Judy, leave yourself up. We have functions in one variable. What's the shape of these functions? Functions in one variable, it will appear to you in this way. F such that from R into R. Once you read this statement, this mathematical statement, you understand that you will have y, for example, as a function in x. So just only one variable will enter, and one variable will come out of this relation. Okay? There is another type of functions, which is functions in several variables, which represent Rn into R. And once you see once more this expression, it represents that your function, it's gonna be a relation in x1, x2, x3, blah, 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 up to xn variables, and it will have just only one output. So it is representing n variables, and the output, ya Judy, is just only one. There is another type, Mr. Muhammad, of functions, which is called the vector-valued functions. طبعا كريم, احنا اتكلمنا, we talked about the case, just only one variable and one output. Several variables and one output. Judy, what's going to be the case if you have F is mapping or translating elements from Rn into Rm? This is called vector-valued function, where the output is not going to be one function, but it's going to be several functions. So simply, this represents F, where the input is x1, x2, blah, 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 up to xn, while the output is y1, y2, blah, 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 up to ym. Those are the variables. Each one of these functions, or each one of those, are a function by itself. يعني مثلا, for example, I can say that f of x, y, and z will appear in x squared plus 2y, 3z minus y, 2x plus z. In this case, I have three inputs, which are x, y, and z, and they have three outputs, which are x squared plus 2y, it's a function, another function, which is 3z minus y, another function, and the third one is 2x plus z. So here is the input, it's completely, okay? It's not going to be just only one function. Like, what's an example for this guy? It's very, very simple. Like also f of x, y, and z, for example, equal to x plus 2y plus 3z, which is an equation of a planet. Okay? So you enter three different variables, x, y, and z. But all of them, they will act together to give you just only output. The example for the first case and the simplest one is like y equal e bar x, for example, or y equal x squared, for example, and so on. Just only one input and one output. So the amount of applications is enormous. Let's see first how it is written. A real function f on variables is a map, as I told you. Just a transformation, something, a machine, okay? Where f such that the domain, which is D, is a subset from Rn into R. So actually this function takes photos from Rn and it will give you the image in R. We'll connect them together in some app. How they are going to be connected together, it is the equation or it is the function. ماشي? Okay, very good. D in the domain of f, f is defined by the algebraic expression. Okay, how to write it? It's written like this. F of D, which is f, a function of x1 up to xn, such that x1 up to xn belongs to the domain, and that's the range of f, which is the set. I'm talking about this guy. F x1 up to xn, this guy. This is the result of substituting by these values in your function. I think that's really fair enough for functions. In this part, we will be interested in identifying ايه اللي يهمني. طبعا ده مش هتلاقيه في البي دي اف بتاع اسمه. اوكي معايا جودي. In this part, we will be interested in identifying the domain and having knowledge to identify the level of service of a function, if required, as you will see. Okay, I think this definition has it all. He is giving you the summary of all of this. A real function of n variable is a map from Rn into just only one output. Okay, this guy is a subset from the range. So I'm inserting x1, x2 up to xn, and I'm getting just only one value, a function, all of them. Okay, that's the representation that I'm telling you about. Today's agenda, we will introduce first some of the well-known quadratics and the curves. It's really very nice, it will be very nice for you just to memorize the names of those equations. You already passed through some of them, but we will gather all of them today, okay? Number two, famous surfaces in 3D, then identifying the domain, how to get the domain of a certain function, as you will see. Then the level curves and quadratics. When I do a level curve, what's gonna be the shape of the quadratic that you will have, how to write its equation, how to state the shape will be like this. Okay? That's the agenda of this part. Let's start first with equations in 2D. To keep in mind those equations, you're already familiar with most of them. So most of these equations, you already know them or know what they represent. I will start with conics and the quadratic surfaces. The first or the most famous conic is the circle. What's the equation of the circle? Yes, Judy, you are right. It is x squared plus y squared equal certain value. I usually call it a square or r square, where this is a circle, where the center is the origin, and the radius of this circle is just a. So that's an equation of a circle. Try to remember it. If the center is not the origin, if the center is not 0 and 0, for a general case, if it is h and k, the equation will be x minus h to the power of 2 plus y minus k to the power of 2 equal r squared, where r is the radius of this circle. Of course, remark the negative sign, Judy, that we have x minus h, so it's an h. Y minus k, so it's an k. That means if I have x plus 2 to the power of 2 plus y minus 3 to the power of 2 equal 9, we are talking about a circle where the center is at negative 2 and 3, and the radius is equal to 3. You can't say positive or negative because the radius is a lens. You don't have negative lenses, okay? So that's an equation of a circle. If we just try to contract or to push or this part of your circle, you will have the equation of an ellipse. The equation of an ellipse, okay, it has a difference than the circle. What's the difference between an ellipse and circle? The difference between the ellipse and circle is the ellipse has two radii or semi-minor axes, major axis and the minor axis. Its axes or its radiuses are not equal. So the general equation of an ellipse, it is like the general case. Let me start with this: x squared over a squared plus y squared over b squared equal to 1, which is an equation of an ellipse where the center is at the origin, the semi-major axis, it is on the x direction. I usually will symbolize the major axis by A and the minor axis by B. And that's the major axis, and this guy is the minor axis, as you can see. That's an equation of an ellipse. Of course, this is written in front of you. Major axis is the y-axis because it has A. The minor axis is on the x-axis. So this, alhamdulillah. So this ellipse, as you can see, it's more flattened on the y-axis than on the x-axis. If I'm talking about this guy, this is the one that I represented to you. If you remark, I will have x squared over a squared plus y squared over b squared equal 1. So the semi-major axis, semi it means half. So the semi-major axis, it is beneath the axis with the larger diameter. Are you with me? Okay, now I'm talking about x squared over a squared plus y squared over a squared equal 1, which is a circle. So now, if I'm changing the radiuses, so I have x squared over a squared plus y squared over b squared equal 1. ماشي؟ طيب, what if we have something like this, and which is really very similar to the equation of an ellipse? The only difference, Karim, instead of having a positive sign, the sign will be negative, which is x squared over a squared minus y squared over b squared equal to 1. And it is called, Ms. Judy, a hyperbola. It's called a hyperbola. And that's the shape of a hyperbola in this case. What I want you to memorize is you have an axis with positive sign and an axis with a negative sign. The axis with a negative sign is going to be the axis in the middle, or the axis of mid-symmetry. So your hyperbola will be, as you will see just in the next slide, this is your hyperbola. Here we go. That's the hyperbola. This curve and that curve, both together, they are called hyperbolas. So I have an ellipse, I have a hyperbola, I have a circle. The circle is a special case from an ellipse when the two radiuses equal to each other. Okay. The hyperbola, same way. If you have negative sign in front of y, it's going to be symmetric around the y-axis, or the y-axis will be in the middle. If it has the negative is in front of x, so it will be symmetric about the x, as you can see. If I have the equation, of course, all of this has plenty of information and the details, but this is the shortest list regarding the laws and the names of these conics. Let me show you how to draw a hyperbola. I will start with the main axis. This is the x-axis, which is the main axis. Then you will have your secondary axis or the minor axis. If the equation is x squared over a squared minus y squared over b squared equal 1, the first thing to do is to get the square root of a square and the square root of b squared, identifying a and b. Then I will start by determining the focus, the vertex, and so on. All of this are trivial for us at the time being. We are not really interested, but to know the steps exactly if I want to draw it as accurate as possible. So I will get all these points. That's the center, that's the point to the directrix, that's the vertex, that's the focus of this hyperbola. Then I will start by drawing the square of this guy, or this value, which is b. I will insert a horizontal line, as you will see, and then another line with the same distance from the x-axis. In a similar manner, Karim, I will do a to the left and the a to the right. Now I have a rectangle. I will now connect the diagonals of this rectangle. Let's connect them together. Those are the two asymptotes or major asymptotes for a hyperbola. The hyperbola will move in such a way to be an asymptote for this line touching at A, then an asymptote for will touch an asymptote. It means the curve will touch this line but in infinity. So it moves beside it. Okay? So that's as I told you, those are the distances. We already have them. Those are the directrixes. All of this are lines to help you. And then this is gonna be, as you will see, those are the asymptotes. And finally, you will have your guy here, which is the hyperbola. Those are the two parts of the hyperbola. Of course, for each hyperbola, there is a conjugate hyperbola. What's the conjugate hyperbola, Karim? Same equation, but in front of positive 1, there is negative 1. And how am I going to draw it? It's gonna be on the other two parts. It's gonna be one like here, and one touching at B capital, and the other side is touching at B dash. I believe I've already also sent it here, draw it here, as you can see. So if the equation is like this, that's gonna be the equation of your hyperbola. If this is negative 1, like this one, this is gonna be the conjugate hyperbola for your main hyperbola. The most important thing on what I've given you at the time being is I want you to memorize the name and the shape. The name and the shape. It will make you very comfortable down the road with what's going to happen. Okay? Any questions? Okay, very good. معايا Mr. Muhammad? Okay. Let me go to another part where all the third conic, I believe that's enough for those. The third conic is a remarkable one, which is the parabola. And those are the shapes of parabolas, or the prospective parabolas related to their equations. The general equation of a parabola will go like this: y squared equal 4a of x. That's the main equation. And it's usually symmetric around the x with no power. So in this case, once you saw this case, معايا Mr. Karim, it's very, very simple. All I have to do, this is the x-axis, that's the y-axis. The axis with no square, which is x, so it's gonna be symmetric about the x-axis. From this equation, the vertex is the origin, so that's the shape of your parabola. If I have negative sign here, instead of being symmetric and in the direction of the positive x-axis, it will be in the direction of the negative x-axis. So if this is a negative sign, your parabola will take on the other side. Like, what if I have y equal 4a of x? I'm sorry, 4a of x squared. In this case, it will be symmetric about the y. Okay, because y doesn't have a square. So the equation and looking upward, so it's gonna come up like this guy, which you are familiar with your quadratic functions. And if I have a negative sign, y equal to negative 4 of a x squared, then the shape, it will be symmetric about the y, but looking down, as you would see. Those are the four shapes, and here is the vertices, the focuses, the directrices, the equations, and everything. What I really do care about is how to grab the shape, or how to imagine the shape of your parabola. So, for the time being, I have an ellipse, circle, hyperbola, and parabola. I'm going to talk more, just a little bit, about the parabola, because it is usually you will find this quadratic equation most often. So, if the equation is y equal ax squared plus bx plus c, that's an equation of a parabola, okay, but with a vertex different than 0, 0. Okay, so how to get the vertex and how to graph it. If you could make a completing square to put this equation on this form, it's very, very simple, just making a completing square and trying to rewrite or to rearrange this equation to be on that form. In such a case, the vertex will be D and E. Will be at E and D in specific. E in the direction of X and D in the Y coordinate. Okay? And depending on K, if it is positive, it will look upward. Negative, it will look downward. For example, if you have an equation like this guy, which is simply, as you can see, which is y equal to x squared negative 2 of x negative 3. So what I expect from you, once you see this equation, you will tell me it's a parabola. You knew it's a parabola. Okay, I need to sketch it, or if I need to. Okay, how to sketch this equation? In order to give a sketch, you need the vertex. In order to get the vertex, I believe this is really very helpful for you if you just try to put it on this shape. Like, how to do it? I will need completing square. Yes, Monsieur Youssef, y will equal to, open a bracket to the power of 2, leave this number on its own, divide x squared on x, and divide this number on positive 2. So the remainder will be negative 1. Now Mr. Muhammad try to expand this perfect square. The first square is going to be x squared. First, second times 2 is going to come up to negative 2x. The last square is going to be positive 1. Kareem, do you have positive 1 in here? No. So I will add it as negative 1. Now I have an equivalent form to the given equation. You said, try to expand it once more. The first square, which is x squared. First, second times 2, negative 2x. The last square will be positive 1. He will find who's waiting for it? Negative 1 to eat it. Negative 3, it's negative 3. We are in the best case scenario. So you have now y plus a 4 equal to x minus 1 to the power of 2. Please look to this equation and look to the general formula. Now I know the vertex. Where is the vertex?
Negative.
The vertex will be at
Negative 4.
1 and
Negative 4.
negative 4. That's the vertex. Looking upward or looking downward? Look to the sign in here. Upward. So all I have to do to give a very good sketch for this function, that's the x-axis, that's the y-axis. I will go directly at 1 and move down till -/4, that's the vertex. And then now I need to draw my parabola, but I will face a problem. It will hit the x-axis. How to get exactly where it's going to cut the x-axis? It's very, very simple. I will take this equation, which is y equal to x squared minus 2 of x negative 3. And yes, I will solve it with the equation of the x-axis. What's the equation of the x-axis?
Y equal x.
0.
Oh, yes.
Then I will equate them together. So you will have x squared minus 2x minus 3 equal to 0, which I believe can be easily solved. 3 and 1 equal to 0. That's a negative, that's a positive. So actually, it will cut x at
-1.
3 here
-1.
and here at -1. Now I can draw a very near shape for this quadratic function, which, as you can see. So it's very, very simple, and you already know most of these information. Okay? So this is how to graph something like this. This is the vertex, which is 1, -4. Handable. I need you to be 100% capable of doing something like this. معايا يا شباب؟ أي مشاكل؟ تمام. حلو. كويس. So, tell me now, from the beginning of our lecture, what are the shapes that we did go through? Circle,
Ellipse.
ellipse,
Hyperbola.
hyperbola, and parabola. صح? Okay, let's continue. Now, I'm going to take شوف الحركة دي خطيرة بجد يعني. خلاص؟ Now we will talk about quadratics or surfaces. What you saw previously, most of the famous shapes, okay, in 2 dimension. Now we will add another dimension, or we will talk about R3. Usually, R3, it is gonna be a function like f of both x and y. So the expectation of having functions like this, it's simply f of x and y. This is what you would see down the road. And usually we symbolize f of x, y by z, which is the third coordinate. So in 3D, I will have the z, the x, and y. This is the y-axis, that's the x-axis, and that's the z-axis. Now I'm talking about 3 dimension. Okay, in a similar manner, as I told you, معلش كمان مرة. بس حركة
شغل عالي.
شديدة. مدفوع، مكلف، أنا مكلف جدا يعني. Okay, quadratics are surfaces in R3. This is the general equation by the idea. That's the general equation describing all the shapes that you will see, which is a number in x squared, a number in y squared, a number in z squared, a number in xy, a number in xz, number in yz, a number in x, a number in y, a number in z, and just only a solid number, a constant, equal to 0. That's the general equation. This equation can be a lot of things. The most known shape is the sphere. The sphere equation is very, very simple. It is x squared plus y squared plus z squared equal r squared, which is a sphere with center 0, 0, 0 and the radius equal to r. If the center is not the origin, so it's going to be, for example, h, k, and l. So it's going to be x minus h to the power of 2, y minus k to the power of 2, z minus l to the power of 2 equal r squared. Of course, the center or the origin, the center of the new sphere is h, k, and l. Remark, it is on the same way, like expressed in the previous equations. I am talking about x minus something, and I'm taking this value positive. So I'm still with the same trend in reading these equations and getting the centers and the vertices and so on. Okay, that's the shape of a sphere. So what are those? Those are the space. The space, actually, this part is 1/8 of the space. Because the space, we will look to the space as this is by 1, where you will find the x-axis and the y-axis. And actually, if we can imagine, we are sitting in this room to have the x-axis, that's the x-axis, that's the y-axis, and the z-axis in the front corner, as you will see. In this case, I'm talking about this quarter. But in the case of having z positive, so I have 4 quarters, which is Q1, Q2, Q3, and Q4. Okay? Q1 where x is positive and y is positive. I'm sorry, x is positive and y is positive. And then you have Q2. Okay? Q2 where you will have x is negative, here x is negative, and the y is positive. And then you will have the third quarter where x and y, both of them are negative. And then you will have this guy where x is positive but y is negative. So actually, those are 4 quarters. And you have another 4 which are in z negative 1. So this is actually the space. So if the sphere is with center as a general equation, ABC, for example, the main equation of the sphere is going to be x minus a to the power of 2, y minus b to the power of 2, z minus c to the power of 2 equal r squared, and that's an equation of a sphere. Okay, there is, طبعا, of course, you will have by 3, which is the plane containing the x-axis and the z-axis. You will have by 2, Mr. Muhammad, which contains the y-axis and the z-axis. And of course, the most famous by 1, which is x-axis and y-axis. Those are the 3 main planes. Okay, by 1, which have x and y. By 2, which usually we symbolize it by y and z, or the yz plane. Okay, so sometimes we say this is the xy plane. For this guy, that's the xy plane. For that guy, this is y z plane. For this one, it's the xz plane. And this one is an xy plane. Usually, we do something like this. معايا يا شباب? Okay, really, really good. So, those are the names of the most famous planes, as you would say. Okay, now we will move in general, that's the sphere. So, if I give a look for this, Ms. Judy, once you look to this equation, okay, you will discover this is a sphere. Why not is not a circle?
X, Y, Z.
لأن X فيها 3 variables. لكن الcircle it will have just only 2. صح؟ طيب الراديوس هنا بكام؟ الراديوس is 4. يبقى إذا ده الشيب بتاع السفير. طبعا هنا خلي بالك أنا متعمد إنك تشوفي by 1 is cutting because the center is the origin. So you have now 1/8 of this sphere. It's in front of you. The other 1/8 is from blue or beneath the by 1. And then the other 2 1/8 on the other side, and so on. This is from another angle. If I moved up and looking up from up, this is the shape that you will see. That's the sphere, and as I told you, those are 4 1/8 of this sphere, and the remaining is from blue. Okay, from blue by 1. Okay, that's also the general equation of a sphere, where the center is 4, 3, 2, radius is 4, and in this case, as you remark, the center of the sphere is away from the origin. So if you look also from above, this is going to be the shape. And if you look from a side, this is going to be the shape. The center is going to be somewhere in here in the first 1/8 of the space. Okay, very, very good. What's called a trace of a service, and we will برضه الحته دي حاجه لكنه جاي شو ما في وشك يعني. بيقول the curve in which a service cuts a coordinate plane. It is the shape that you will see when one of the coordinate planes cutting the quadratic that we are talking about. That's the trace. Since z, if I put z equal to 0 in all points, I will have the xy plane. That's the equation, or the idea. That's the equation of the y1. So, Ms. Judy, what's the equation of this plan? The plan of xy, it is z equal to 0. In a similar manner, the plan of the zy domain, or the zy plan, it's going to be x equal to 0. And that's the plan of the xz, where y is equal to 0. So simply, if I have an equation for a sphere x squared over 4 plus y squared over 4 plus z squared over 4 equal 1, and I want to find the trace of with the by 1, so what's the shape that will appear to us at z equal to 0 with by 1, which is the xy? All I have to do is to substitute this guy into z. And then you will have x squared over 4 plus y squared over 4 equal 1, which is an equation for a circle, as you can see, with the radius 0, 0, and with the center 0 and 0 and the radius equal to 4. Are you with me? This is mainly why I need you to know the names of the quadratics and what's going to happen after. The xy trace of a circle is the trace as I explained to you. So for this plan, for example, 3x minus y minus z equal 1, if I want to get the intersection of this plan with the by 1, all I have to do is to insert z equal to 0. And in this case, you will have the equation of 3x minus y equal 1, which is a straight line. And it makes sense. If I have a plan, the plan is like a sheet. The plan is like a service like this one. So if I have a plan like the service